Hello, my name is Muhammad Amir Haziq bin Sarudin. My matrix number is DN220049. So for the first slide, let me explain about the introduction of Newton's law of cooling. Okay, Newton's law of cooling states that the rate of temperature of the body is proportional to the difference between the temperature of the body and that of the surrounding medium. This statement leads to the classic equation of exponential decline over time, which can be applied to many phenomena in science and engineering, including the discharge of a capacitor and the decay of a in radioactivity. Okay, for the next slide, let me explain about the applications of it. In forensic science, one of the most prominent applications of Newton's law of chilling is readily apparent. The detectives and forensic scientists record the body's temperature and the temperature of the crime site. When the victim's temperature values are entered into the mathematical formula derived from Newton's law of chilling, the time of death can be effectively calculated. The determination of the time of death is crucial to forensic investigations, as the time of death corresponds to the presumed time the crime was committed.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Nazri, and now I will presenting the calculation part for for first project. So for the first question is to find how long will it take to reach 30 degrees if the room temperature is 10 degrees. So for the first step is to find the equation where from the surrounding medium, and so with the use of differentiation and integration, we will get the equation of T equal to C exponent power of KT plus 10. And after that, for the second step is to at T is 0 and the temperature is 80 degrees, we will find the value of C, which is 70, and insert it into the equation where we'll get T equal to 70 exponent power of KT plus 10. And the third step is at time 20 minutes and temperature is 50 degree. We will insert the value of temperature and time. So we will get the value of K and also C. So the equation will be 70 exponent power of negative 0.02 plus 10. So now the fourth step, where we want to find how long it takes to reach 30 degrees Celsius. So using the same methods, we insert the value of temperature into the equation, and we will get the value of time, which is 44.77 minutes. So the final answer, we we will get the equation T equal to 70 exponent power of negative 0.02 T plus T, and insert the value of T, and we will get the the final answer from negative 1 over 0.02 ln 2 over 7, and we will get 44.77 minutes. So it's take 44.77 minutes to reach 30 degrees Celsius. So for the last question of this project, if to find the temperature that can be expected in the morning. So the first step is to using the same method as a first question, which is we will differentiate and also integrate until we get the first equation, which is T equal to C exponent power of KT minus 32. And the second step, where at the time of 0 and the temperature is 66 Fahrenheit, we will get the value of C, which is 34. And then we insert to the equation, which we will get T equal to 34 exponent power of KT plus 32. And the next step is at the time 2 minutes, at the time 2 and the temperature is 63 Fahrenheit, we insert the value into the equation into the first step of equation, and we will get the value of K, which is negative 0.004619, and we will get the equation to find the next step. For the last step of this equation is to find the temperature at time 0. We will use the same equation before, which is we insert the new value, which is we will get the equation 34 exponent of power over 2 ln 31 over 34 10 plus 32, and we will get the final answer for this question, which is the temperature is 53.424 Fahrenheit. So this is the final answer for this question. That's all for me.
Contoh penggunaan Newton Law of Cooling pada kehidupan harian dengan pembuatan air panas.
A few moments later.
Video tadi adalah contoh penggunaan Newton Law of Cooling pada kehidupan harian dengan pembuatan air panas. Air yang telah dibuat tadi terlalu panas untuk diminum. Maka penggunaan rumus Newton Law of Cooling, kita dapat mengetahui suhu yang diambil oleh air itu supaya kita boleh minum dengan selamat. Apabila takat suhu air panas yang telah dipanaskan boleh mencecah 60 darjah Celsius, ia adalah sangat bahaya untuk kita minum air tersebut. Apabila kita mengacau air panas tersebut dan mengambil masa dalam beberapa minit, suhu yang diingini akan dicapai.